Okay. All right, so this is the problem. So the key here is you need to find u so that the derivative is also in the integral. Okay, here. So that u prime is part of the integral. Okay, so let's do some example. Here, so let's pick integral 6. All right. Compute this one. Okay. So in this case, there are two options. All right. So first, let's do this here. What do you mean two options? Well, the option is taking u1 over x or u equals x squared. Okay, so let's do the wrong thing first. Okay, so what's wrong with this one? If we choose this one, right, so then you see that this is 2x dx. So you have 2x with just x, right? So this gives you e to the 1 over u. Okay, so then this gives you e to the right. So the thing here, x does not appear in the as part of the integrand. Yes, it is, but this is just in terms of 1 over x. Okay, so it's not just x, it's 1 over x. Okay, it's not that it is wrong, but it won't work. Okay, so then let's do the other options. Okay, now if we choose this equal 1 over x though, you get, well, this is 1 x squared dx. Okay, so you see that you have this one. So actually this dx over x squared. So then that is part of the integral. Okay. So if you do substitutions, you get integral of e to the u. Oh, sorry, just e to the u. And this is just a negative part. Let's put it in front. So that's the u. Okay. Now it's easy to solve. So e plus c, then e to the okay. So here's the idea is to be able to recognize what u is. Okay, questions?
How did you get the two numbers that you got for u and dx again?
Which one?
How did you come to the conclusion for u to be 1 over x and dx is equal to negative 1 over x squared?
This one. let's see, because let's see, let's rewrite this as let's rewrite as e to the 1 over x. This is the x over x squared, right? So this becomes e to the u, right? So this is negative d du. Okay, so negative is not clear there. So you see it works when you see that if the somehow the integral simplifies. Okay, so you get simpler problems. And you see that the integral of this is the, you can go back to the our table here, formula 3, you can see. Okay, so that's the idea, is how to change the integral into standard form. Okay, let's do one more thing here. Just take something from the exercise. I won't do the integral, but just show you how to choose u in this case. Okay. Say, let's do this one here. For example, this one. Which you should use. U equals 1. Not that what it's not that the how you choose u, but what kind of u you should choose from this one. Any choice?
How about e to the power of x?
E to the x, right? All right. So in this case, du would be e to the x du, right? So in this case, sorry, this is the x, right? So this is u. This part is du. Okay, so let's write it down. So integral of e to the x 2 plus e to the x dx. Right, so let u equals e to the x. Okay, so then du is e to the x. Then substitutions will give you, this is u, this is, sorry, all right. Oh, let's do this one here. This one. So that becomes the u. Okay. But we know then this should be, what's this? This is a standard part. Well, if you prefer, you can use another substitutions. Let's change color. So let's say v equals 2 plus u. Then the v is the u. Okay, so another substitutions give you this v, this is okay, and this is standard formula. Show formula again. Where is that thing? There we go. This is formula 2. Okay, so that's okay. That is LM of B. Okay, so let's change this back. So this is ln of 2 change to x, then this gives ln. So u is e to the 2 plus there. Okay. And another way is just, well, what if it goes just directly u plus e to the x, okay? Because adding constant doesn't change anything, right? So in terms of integral or differential, so the u becomes just the same thing as e to the x. Right, so then substitutions give you, let's see, here, e to the x dx, same thing, so that's the u. That's directly. All right, so that's the u. C, that which is, you get the same thing, but in one step. Okay. Okay. Questions?
Sir, I do have a question. How do you know if like, how do you know which one you should use? Like, should you use like the x for the, should you use like u for the top or the bottom?
Usually,
or is there like no way to know and you just have to try both of them out to see which one would work?
just first thing is just try them out. Okay. You'll
Okay.
see from the experience which one's better.
Right.
But the main idea is that you should choose u so that the, say, the multiple of u prime is there, so you can substitute. Okay. Let's do some more complicated thing, and you have choices, and you see that the choices, some of them is not good. All right, so let's see. Say problem here. Problem 11. Tangent over cosine square. Okay. So in this case, you'd have two options. Two obvious options, right? Say check U is tangent, right? And the other is you say the cosine square or just cosine. Well, just make it 3 then. Cosine square or just cosine x. Okay. So let's do this one here. First, if you choose u equal cosine. Okay. So u equal cosine. So you do 3 first. Okay. Then you have du equals what? Cosine negative sine x dx. Okay. But the thing here is no sine x there. Okay. So when you substitute, this gives you still tangent, and you have u square. Well, let's simplify a bit. Square dx. But the u here is this there's a what you call there's no sign here. Okay. Actually, you have sign, but in this form, the tangent is, yeah, you have sine x over cosine x u square dx. Okay. And if you observe this, that is the well big. So if you continue this one, you get this is 1 over u because this cosine. So you get here, that's du. Right? So negative actually. And there are another cosine, there's another u. So this u, yeah. Okay, so it works. So you get negative, say, right? So it's negative minus, okay, so just 1/2, 1 over u square plus c. Okay, so that's so it works. Okay. Now let's.
Sir, how did the I still don't understand how sin x dx cos x sin x cos x u squared dx turns into negative du over u3.
So let's rewrite this one here. Okay. Okay, then this is 1 over cosine of x, right? From here. Here we have sine x dx, this part, green, and you still have u squared. Okay, and this 1 over cosine is 1 over u. Right? This is du. Sorry, negative du. Okay, and here is 1 over u. This is defined again by u squared. So this 1 over u cube. This. Okay.
Okay, sir. Thank you.
Okay. So that, all right, that works. Okay, so let's do this one. The cosine square. Okay, so now the du is negative cosine x times sine x dx. Okay, so the substitution, if you okay, now this is just u. The thing is there, but then you have here okay, but then well, at least it's difficult now because you have tangent times dx, and you would like to replace this by du. So what times du here? Well, du here is this. So this is sine times cosine. Here you have sine over cosine. Okay, so it doesn't match with this one. So of course, we can say that tangent is let's see, tangent is, so let's do in other color. Yeah, x dx is sine x over cosine x dx. So then this is, you would like to see this as, say, if you sine x cosine x, and you got to multiply by cosine square x, sorry, now I would like to change this into tangent here. From here to here, this is the questions, how to do this one. So the idea is divide by cosine square, right? So how you do this one? This becomes cosine square. This is cosine, so negative sine over cosine dx. Okay. So then this gives you negative tan x dx. So what is this? This is u. Okay, all right, so this is u. Okay, so then this gives you negative tan dx is actually du over u. There. right? So then, so far we're okay. But the thing here, okay, let's see. In previous one, we have negative u 1 over u cubed. Here we have 1 over u squared. Why is it so different? Okay, let's see. Let's do integration first. This gives you just 1 over u. Let's see. Okay, and 1 over u is 1 over cosine squared x. And do we miss anything? Ah, we do. We did. We did miss this one. Derivative of cosine square. You have this number 2 here. All right. Okay, so we have should be 2. Should be 2. So this should be be 1/2. Uh, 1/2. This is 2. All right, still same thing. Right. So, but it's more complicated in this part. And see the first one here. What if we choose tangent? Right. So the u. What's the derivative of tangent?
Second square.
Is that secant square? Derivative of tangent? Yes. That's secant square. Secant square x. What is secant? Secant is 1 over cosine. So you can say this is right. So our in problem, let's see, what is that? Tangent over cosine. Write this down as this one here. Well, this is du. Okay, this is our u. So you get just integral of u. Okay, so then this gives you 1/2 u squared plus c. Okay, so you get 1/2 tangent square plus c. Hey, the thing here, well, on the other two give you 1 over cosine square, but this is tangent square. What's wrong with that? So let me rewrite this. Don't forget one thing. 1 over cosine is there. Right? So same thing here. This is also 1/2 secant squared. Well, two of the above methods give you secant square. Here you get you tangent square. What's wrong with that? Note. And secant square. And 3 tangent square. So it's 1/2. So why is it wrong? Not wrong, but why are they different? Okay, you see how secant square and tangent square relate? How do they relate it? Okay. Square minus 1 is secant square. So, all right. So this is our, let's say, formula. So what you get here is, so 1/2 secant square x is actually 1/2 secant is tangent plus 1, right? Tangent. Okay, so this gives you 1/2 tangent square plus 1/2 plus c. All right. See here, that's the key. You see, those two use same c, but actually those c's are different. All right. So these two differ by concept. Because they are only different by this 1/2. Okay. So that's one of the main difficulty of the doing integral, because you might get different answer using two different methods. Okay, and both are correct. What matters is you're doing the correct things, the correct methods, and if you follow using correct way, then you're okay. Even though, so you might get a different answer with your friends, but you're both correct. Okay. Let's do one more thing. Can you see directly here? Problem 26. What supposedly you choose for you? Let's do this one. 2. Okay. The thing here is that this is the indefinite integral, so they're the same thing though. All right, so let's do this one. The previous problems give you 3 choices that works. Okay, 3 options. All works, right? The difference that, well, which one is probably easier than the other. Okay. All right, so then let's do this one. Okay, so naturally you have 2 options. Cosine or u equal sine. Okay, let's do this one. Let's do both. When you choose cosine, x, then u is negative sine x dx. Okay, so sine x dx, then this one here. So when you use substitutions, you get e to the u, and this is negative d. All right, so then it would be easy. All right. Okay, sorry for interruptions. All right, so let's do the second one. Then that's easy. Okay, and the other one is choose sine x. Then du equals the sine cosine. Okay, now the thing here is that what you have is sine x times dx. So there's no way you can put this cosine. All right, unless it's if you use this one, you should change this as 1 over cos, sorry, sine square x, right? Okay, so then this gives you 1 over u square dx. Let's see, sorry. Oh, all right. So let's see. Sine x. All right. So if you substitute this, sorry, I should use so 2 to the q cosine x. Sine x is u times dx. Okay. And dx is, say, from here you get dx is du over cosine of x. Okay. So it's getting more complicated in two. Well, this is not still in x, not in u. You have to express cosine as sine. Cosine x is 1 over there. So this is our u squared. So it's u. This is dx is just say this is u over cosine. Again, cosine is all right. So let's see. The thing is, it's just getting ugly. Okay, complicated. Okay, so you don't want to have this one. Not it is wrong, but this choice gives you more difficult problem than the original one. Okay, so that's why here this one works. Okay, and this one doesn't. All right, and by doing more and more problems that you will recognize which one works, which one's not. Okay, because that's only experience, and we'll tell you that. Okay, questions?
Actually, sir, can you show the final answer for?
All right, so this is the final answer, right? So, but in terms of u, you just need to replace this negative e to the u here is cosine x. Sorry, let's see. What we are doing here is that the indefinite integral, right? So if you, let's see, what 0 to pi over 6. Let's complete this one. Sine. Negative e to the cosine x with this boundary. Right, so pi over 6, cosine pi over 6. Pi over 6 is 1/2 square root of 3. Yes. So if it's 0, if you plug in 0, then just 1. Okay, so then this e to the minus there. Okay. Okay, questions? All right. Let's say 38. I won't write this down, but just try to recognize from here. Okay.
Sorry, I think I have a question for previous
Uh-huh.
question. It's like the question is to over why is E there?
Sorry?
Why
Your
is
question?
E there? Why is E there, sir?
E
You change
here?
the question is 2 over cos x, but
Okay.
why it's changed to E
Oh,
over
sorry,
U?
sorry. Sorry, you are right. You're correct. This is just, sorry. I thought that that's the problem. So this is 2.
Okay, sir, thank you.
Yeah, should be there. So this is 2. And the integral should be multiplied by ln of 2. There. Okay. So let's this one. There. Okay. All right, so see if you recognize what's the choice for you here. 38. What are your choices?
It is to a negative T squared minus 2T minus 5, sir.
Uh-huh. And t plus 1, but you have 2 choices. But the thing here is that if you choose this quadratic, right? So minus t squared minus 2t plus 5, the derivative is 2t minus 2 minus minus, so plus. So that's exactly t plus 1. So multiple of t plus 1. Right? So that's a good choice for this one. So in this case, you should check this one here. Because if you choose this one, then t plus 1 dt becomes a multiple of du. Okay. While if you choose t plus 1 as your u, then the t equals du. So you won't be able to simplify this exponential. Okay, so that's the reason we choose this one. Okay, so that's the reason. All right, so let's do something else. If you see from the standard table, you find two. This one, 13 and 14. Some special form that you get tangent inverse or sine inverse. Okay, so the form is this one here. So actually, I usually use this formula instead. 1 minus u squared. Then this gives you sine. Okay, and this tangent plus just one here. Okay, so that's the idea how you get the sine inverse or tangent inverse arc sine or arctan. All right, so that's related to this problem. Let's do this one. Okay, so let's do 48. Now the key here is that, well, this is a square, right? So this is similar to, should be similar to what we have earlier. What we mean earlier is this formula here. So it's this integral of the okay. So this formula over here. So this is square. So we should be able to write this down as this one, u plus 1 plus u squared. Okay. So how we do this one? All right. So in this case, let's choose this one. Okay. And it is completing the square. If you recall this this term. So what completing the square means? Let's write this down as a square. Okay, so that's plus, oh, sorry, minus 2. That's a square, right? So, but then it has a constant that we should subtract. Okay, so that this equals to x squared minus 4x. Okay, so plus 9. So then this gives you plus 5. Okay. And well, this looks like this one now. Our u is this one. Okay. But then this is one. So let's make this one. So this becomes 1/5. Right? So if we, but now this should be u here. But then we have okay. Right. So now our choice for u here is that u be the then our du here is just x. Okay. So with substitutions, if you this is just 1 so 1 over there, right? Because this is equal to this one. Use this one. Right? And dx, what is dx? Dx is just u over square root of 5. Okay. So this equals to, let's see, this is du. All right, so this is du. So take, this is just 1 divided by 1/5. This becomes 5. Take it out. This is u squared plus 1. Okay, so you have, sorry, square root of 5. Okay, so 5, 10 inverse u. Then u here is there. Okay.
Sir.
Uh-huh.
Isn't dx equals to root 5 du, not du over root 5?
Oh, the root? No.
How do
This
you
one
get u over root 5? I'm still slightly confused about that.
Okay, here. Or just write this down like this. This is just like 1 over square root of 5, right? There. Right? Take the u. Here, okay. This is constant, right? So you take that out. Let's move this one way. So this constant, take it out. Derivative of x is just 1. Derivative of just 2, 0. Dx. Okay.
I'm still confused, actually.
No, take derivative of this. 1 over a square root of 5 is just constant. You take that out. Or here we go. Take the derivative of each one. Okay. This is just 0. Okay.
Right, okay.
Sir, can I ask, sir? Why is it du over a square root of 5? I think it should be square root of 5 du, sir.
Yeah, that's also my
Right,
question.
right. You are correct. You are correct. Yes, yes. Du here is that, right, square root of 5 du. Right, right. Yeah, right. So, in this case, what you have, if you multiply, okay, yes.
Sir, I have another question.
Okay, questions?
Yes, sir, another question, sir.
Mm-hmm. Sure.
When completing the square, sir, I want to ask, how did you get 1 over 5?
1 over 5. Oh, this one here. All right. The idea is to write this down as a multiple times 1 plus u squared. Okay. So it should be 1 plus u squared. Okay. So what we have here is that the square is there. Okay. But this is 5. So we try to make this 5 to 1. So by dividing by 5, 1 divided by 5. Okay. And now put this 5 inside the square. So you have x minus 2 over square root of 5 squared. So this is our u. This is the multiple. Okay. So you got to understand what the objective is. Okay. Our objective here is change this into 1 plus u squared times some constant.
Okay, sir. But how did you get 1 over 5? Because when you open the brackets, shouldn't it be like x minus 2 square over 25 plus 1 over 5? If you open the brackets.
Open the bracket this. That's the thing. We work backward here. Okay. First, you get rid of this 5, make it 1. Right? Divide by 5 here. Okay. But this is square divided by something. What you want to have is the whole thing is square. So this 5 is not squared, but the square root of 5 is squared becomes this 5. All right, just one more exercise, just the squaring thing. Let's pick same thing here. Let's do this one here. 9x squared plus 18x plus 10. 9x squared plus 18x. Stop here. So this is different thing. 9x squared plus 18x plus 10. Write it down as like this, as a multiple of 1 plus u squared. Okay, so let's try this one. Okay, first you probably want to get rid of this 9. Okay, or 9, or it's already there. So let's this one. Okay, so this gives you 3x plus is this going to be, say this is 1? Let's see. How many? Sorry. P1 6 6 2 9 3. There, right? Of course, we still have to add something there. Okay, because then we have 3 9 square, right? So then 2 times 3 times 3, so 18x. Okay, the only thing is you should subtract 9. All right, and plus 10. There. Are you with me?
Yes.
Okay. All right. So let's. Okay. So this 3 already there. It's already there. It's actually easier because now this is u squared plus 1 already with the u equals 3x plus 3. Okay, so let's compute the integral now. X. This is a dx over 3x squared plus 3. Right? Now we compute. So let u equals 3x plus 3. Then our du would be 3 dx. Okay, so 1 dx is 1/3. All right, so this would be 1/3. This is du. This is u squared plus 1. Okay. 1/3 and inverse u plus c. Okay, so in the end you have 1/3 tan inverse arctan tangent is 3x plus 3 plus 3. Okay. If this term is not 1, of course you can do just by the formula. Sorry, let's go back to the beginning. Because our formula gives you actually there, not necessarily 1. Sorry, this a squared, not necessarily 1. Okay, so if you recall or memorize this formula, then that's all right too. But for me, usually this just 1, that's easier. Okay, so that's the basic idea. This one is still the same because you're actually trying to express this a squared minus u squared as whatever the problems to this one. The difference is that this is inside the square root, but it doesn't change anything in terms of simplifications. They're different only here. You have sine in up sine. Here you have without the square root, you have tan inverse. Okay. Any questions?
Thank
right.
you, sir, for answering the question.
If not, then I'll stop here. Let's